Facebook page, Lunar Eclipse Alaska Style, and it's a 360 view, really cool, of a lunar eclipse with the auroras in Alaska. And this coincides. I just wanted to point this out because it matches perfectly with the understanding of a convergence of cosmic rays up in, I know these are not necessarily cosmic rays, but they're all converging. I'll play it for you to help you understand. You see the lines there, the vertical lines, they're all converging, right? They're not diverging, they're converging the higher you go, right? So let's show there's the moon here. Where are you, moon? There it is. See the moon over there in the center? And that also too is another, gives you an understanding that the moon is a real object. Some people don't think that the moon is a real object. Well, it is. And the only reason that you would see stars behind it sometimes, like the people within that one community think that's possible, well, that's because I talked about before, there's glass in the sky and there's layers of glass in the sky that create a cloaking effect. And so that's why that is happening. But really, I just wanted to point out how the vertical striations of the auroras are all converging. Let's get a better shot over here. Go back here. You see how they're converging? See the vertical lines? They go up to the center like that. Well, yeah. Oh, yeah. Given this is a wide angle lens, but still understanding that. See how the vertical radiating lines are all converging? Do you understand what I'm talking about? Well, that gives you an understanding that that's how light works within the Earth. That's how cosmic rays work within the Earth, behind the celestial sphere. The octahedron, the light from the northern side, is coming out at the northern side and it's going through the seam of the Milky Way band. And that's how we get the cosmic rays. Light is really slow up there because of the high superconductive state. And what it does is that light, that cosmic ray that exits out of the Milky Way seam, sometimes, you know, there's little holes in Cygnus and other places like that. Well, that light that exits out, the cosmic rays that exit out of that seam, they interfere with the collimated light that hits the back of the sun. I talked about this before, and that's actually what slows the sun down slightly when the sun is in the northern hemisphere. You're going to get 179 days while the sun is in the north versus, no, I'm sorry, let's switch that. 186 days while the sun is in the north and 179 days while the sun is in the south. So it's moving faster in south because there's no interference of the cosmic rays hitting the back part of the sun, the light that's hitting the back part of the sun. There's no interference there. And so that's where that's happening. I explained that before if you watch my cosmic rays video. But you see, look at that. It's converging. See, the lines are converging. Okay? Just like the cosmic rays, where I talked about negative meniscus of the cosmic rays. Okay, so that's... Just go on for a little bit more here, Steve. Okay, yeah, it's causing a negative meniscus. The light, the cosmic rays are hitting a negative meniscus and branching out like that, and that's how we get that. That's why it's a mystery to them. Because they don't understand that the light is actually speeding up as it leaves the celestial sphere, right? I talked about that before, even with my slow light video. I talked about how the light actually, okay, it's going to leave the celestial sphere, and then it's going to be in that area between the celestial sphere and the glass sphere that covers the sun and the planisphere. And so it's going to be really, really slow, like incredibly slow. And then as it passes that area and it goes into the area between the moon glass sphere and the sun glass sphere, it begins to speed up. And that area right there is the dewar. Remember I talked about that? The dewar? And the dewar is going to create a high vacuum state, right? So it's going to increase the light rays. The velocity of the light is going to increase, not as fast as we view the light over here, 186,000 miles per second or something like that. It's still very slow, but considerably faster than the area between the moon glass sphere, I'm sorry, between the sun glass sphere and the celestial sphere. What I was looking for, this one here, EME bounce explained. If you look at that video, you will understand that light is slowing down. That light is slowing down. You watch on the left here. You pick that up, yeah. So it's going to slow down as the light passes through the glass sphere that covers the moon, where there's negative refraction. There's a phase conjugation, wave coherence happening there, and so it's reversing things, reversing refraction, decreasing the terminator line of the moon, and all that stuff. I have it listed there at the top left there, but that's what's happening. And so as the light, the cosmic rays, I got a video about that too. I talk about the cosmic rays in the center over there, the top and northern side, as it goes through the Milky Way band. You see Cygnus right over there? See how it's the spine of Cygnus that's going right across the Milky Way band like that? Well, that's where some of the openings are. So it allows the light, the cosmic rays, to penetrate through the seam. See, the celestial sphere is divided into two. It's dipolar, right? They will even say that with the CMB. It's dipolar. You understand? That's how the light bends up toward the center like that. That's why. And see, they even give you this illustration. It's hitting a negative meniscus. See that green little thing there? So that's what's happening too with the auroras. Same understanding. Well, yeah, they're converging to a point. And that's what you need to understand. And that's why nobody will ever come up with a better answer than this for the cosmic ray, quote, mystery. Because it's inside the concavity of my Earth. Okay? Understand? Okay. There you go.